Hey folks, in this video we're talking about the basics of ions. So let's make moves with that. I want you to be able to define a cation and an anion. I want you to be able to locate where cations and anions are going to be found on the periodic table, or rather elements that form cations and anions. And I want you to be able to determine the charge of certain ions using the periodic table. And I want you to be able to explain why ions are important. So some new vocab will be cation and anion. And let's get rolling. So, types of ions. Ions, as we've discussed in other videos, are charged atoms. They have an imbalance of protons and electrons, not the same number. So this results when an atom gains or loses electrons, not protons. So the number of protons is pretty much always going to stay constant. Atoms can gain or lose electrons, but not their protons, in order to form ions. And so different ions are going to have either positive or negative charges. And our charge, if you recall, is equal to the number of protons minus the number of electrons. So if we talk about positively charged ions, we're going to call these ones cations. Fun, new vocab. Cations. And I remember these as neutral atoms that have lost electrons. They give away those negatively charged electrons, so they're left feeling nice and positive. And so the T in cation, to me, it looks like a plus sign, and that is how I remember that cations are positively charged. We also have these negative charged ions, and these are called anions. Fun. We get these when a neutral atom gains electrons, or when it picks up those negative electrons, and then it becomes negative. And so N in anion, I remember for negative. You could say this is a negative ion. Anion. Fun, fun. And so here we can see how different elements on the periodic table form ions. Oy vey. That's a lot to look at. Let's talk about that for a second. Will elements form cations or anions? We've already discussed this a little bit, but metals like to form cations. All of the metals are very content to give away their electrons and form cations. Our nonmetals like to form anions. The nonmetals on the right side of the periodic table, I'm sorry, they're on the left side of the periodic table, right, left. They like to gain electrons to form anions, negative ions. And so the noble gases typically do not form ions. Noble gases, as we've said, are non-reactive. They're very, very chill. And so they don't like to gain or lose electrons. Very stable, happy with the number of electrons they have. And as it turns out, when other elements form ions, not anions specifically, when other elements form ions, they're typically going to end up having the same number of electrons as a noble gas element. And that's because the noble gases have a very happy number of electrons. And we'll understand that more as we study electron configurations. It's kind of weird, but actually it's not, because the noble gases are very stable, so it's from their electrons. Anywho, atoms would like to be stable. So as we look at this again, we can see over here we have our nonmetals forming negative charges over on the left side of the periodic table. And if we, left side, and we can see over here, all of our metals like to form positively charged things. The one exception is that we have hydrogen over here as a positive charge. And hydrogen, as we know, is a nonmetal. But hydrogen is a little squirrely, and hydrogen can form either positive or negative charges, because hydrogen's cool like that. Very needy. Not needy. Anyway, what charge will ions have? Because as we look at this, I can see some of these dudes do not always, there's multiple charges listed. Well, some of these dudes have just one charge listed. Well, certain elements will always form ions with the same charge. And these are going to include our alkali metals, our earth alkali metals. Remember, those are the two groups on the first two groups on the right side and the left side of the periodic table. And we also have our nonmetals. And so these are going to be based on the group. And there's a few other metals that always form specific charges. This would include silver, cadmium, and zinc, gallium, and aluminum. And the way I remember those guys is, I'll show you in a second. But all the other metals like to form ions with different charges. And that allows them to do really cool chemistry. So here is our trends for specific ionic charges. We've got a +1, a +2 on the left side of the periodic table. And here are those dudes who I mentioned always have specific charges. And they're nice because we have this +1, and then we have this +2, and we have this +3. And I just kind of remember when I studied chemistry the first time that they made a sort of a staircase going up from silver to aluminum. I don't have a clever way to remember that. Sorry, the internet might. And so if we look at our nonmetals, remember our noble gases have a 0 here because they don't like to form charges. Our halogens all like to form -1 charges. Oxygen and its homies like to form -2s, and nitrogen and phosphorus like to form -3 charges. And so I always remember this by going, all right, I'm going to skip the noble gases and then go -1, -2, -3, counting in from that side of the periodic table. Neat. So these are the dudes with set charges. Everyone in blue can be a little bit weird in their formation of ions. That is a preposterous fish. Wow. So cations and, I should say anions. But when cations and anions combine, they like to form what we call ionic compounds. A compound is more than one element combined together. And so ionic compounds are interesting because they have no charge. They're neutral, despite being made of charged atoms. So when cations and anions combine, there's not going to be any overall charge. What we're going to see is the positive cation is going to balance out that negative anion. So some examples, when I put together sodium and chlorine ions, they're always going to combine in a 1-to-1 ratio as NaCl. And that's because one sodium brings in a +1. One chlorine brings in a -1, so those cancel out. But if I were going to put together, for instance, say magnesium and bromine, these are always going to combine in a 1-to-2 ratio. One magnesium with 2 bromines. And this is because one magnesium brings in +2, while we need 2 bromines to bring in a -2 to cancel that out. And we can also have imbalance going the other way. If I were to put together a lithium and a phosphorus anion, or what we would call a phosphide ion, they're going to combine in a 3-to-1 ratio always. And that's because we need, or it's going to be Li3P, and that's because we need 3 lithiums to make +3, which is going to balance out one of those phosphoruses with a -3, and then they will cancel out. Nifty, nifty, nifty. So, ions in nature do pretty rad stuff. Let's wrap this up. The ions are crucial for my survival and maybe yours if you're not a robot. The nerve cells inside of my body require ions to send signals throughout the body. The brain, as you may know, conducts electrical signals, and these ions, these charged particles, are an important part of that. And if you've ever heard a Gatorade commercial that's like, dude, you need electrolytes, ions are electrolytes. Electrolytes just means that there are ions in there. Electricity, as I mentioned, your brain sends electrical pulses. Well, ions are useful for generating electricity in other situations. A lot of batteries use the movement of ions through them to generate that electricity. And what's even cooler than all of this, I think, that makes all life possible is Earth's magnetosphere. So the sun emits like all these scary, dangerous ions from all over the place. But the Earth has this cool thing called the magnetosphere, which is from metals in the center of the Earth churning around, and it creates this magnetic field that protects us from these charged ions. Here's a rendering of that, and the sun's like, spit out dangerous solar winds, and the Earth's magnetosphere is like this cool lines, and it's like, nah, dog, get out of here. Don't give everything cancer. So that's the end of this video. I hope you feel like you understand ions a little bit more. How we distinguish cations from anions, who's going to form a cation, who's going to form an anion, and also why ions are interesting beyond just the chemistry that we're going to do in these videos. Neat, neat, neat. Well, that's the end of this video. Ta-ta. Have a great rest of your life.